Yes, thank you ladies and gentlemen for coming once again to my channel. I welcome you and thank you for keeping it at this channel. Now, in our last episode, in our last part, we talked about computer vision, and today I want to talk to you about computer vision in the agricultural sector. What did we talk about last time? We said computer vision is a way that computers are able to see like human beings, to know exactly what is happening in their environment. Now, what we are going to talk about today will be precision agriculture. Have you heard about it? Thank you. We will talk about it in length. Precision agriculture. Just don't forget that. Autonomous harvesting robots, plant pest and disease detection, then animal welfare. Now, keep it here. If you have not subscribed yet, please remember to hit the subscribe button and don't forget to hit the bell icon to always get notification when I upload new content. I'll always be here for you as a computer scientist. If you have anything that you want to know about computer vision, please don't forget to put it in the comment section. I'll always be replying to your comments every now and then. Autonomous harvesting robots have been developed and they are replacing humans in picking fruits. Now think about that. If you are picking apples and a robot is capable of knowing which apple is right to pick at what moment, now it would help you because now it would pick only the ripe apples, and this is done by using a computer vision attached to it as its eyes. It is always connected to a camera. This is done through detecting fruits and their three-dimensional position in the tree or in the canopy. Let's talk about another thing, yield estimation. If you're estimating yield, a farmer needs to know, if I have such a big field, let's say a plot of land or an acre, and I have let's say bananas, how can I know how much I'm going to get, or how can I know how much I'm going to get from these bananas? Through computer vision. If you are using maybe an autonomous robot, it would move through and know that the size of a bunch of matoke of this size could maybe be bought at this amount. Or whoever walk through the garden and know that we have maybe 50 bunches of matoke that will be ready in the next 1 week. Then we have others that will be ready in maybe 2 months, and that would be estimating. You would estimate how much your yield will be. Plant pest and disease detection. Always, most of the times, when plants, let's say vegetables, when changes in the environment happen or they have pests with them, they always change either the color of the leaves or you get spots in the leaves. So it is through our eyes that we can know that this plant has a problem. Like when you see the cassava mosaic, or when you see spots in a sukuma wiki leaf, you would know that maybe this is maybe in too much water, and some farmers can suggest, oh, go try and use striker and then it will help you do this and that. Yeah. What if your robot or your computer vision model could help you tell you that? This would be the best, since it would tell you before time or before the disease has accumulated or moved from one plant to the other. If you were able to tell that this disease is called this name and you can use this pesticide or this drug to treat it, don't you think it would be a good idea? Now, think about another thing. If you knew it early enough before it affected a big part of your garden, wouldn't that save you losses? I leave it to you. Computer vision is coming and it will be here to stay. Animal welfare assessment. Now, let's say you have your cows. You have your cows. Let's say they are 3 or 5 or 10 or 100. I don't care which number you have. You could be having 0. If you had a computer vision model or algorithm attached to your CCTV camera feed that monitors the welfare of your cows in an open field. Now, it monitors the movement of each cow and its behavior, its eating habits, the time when it is eating, the time when it needs to take water, Think about it. Now, in case one of those cows has a problem, let's say it is having a fever, or it's not human. Let's say it is sick, and you see there is a little bit or more of laziness in it. Now, your computer vision model would be able to tell if anything changes from the normal behavior of your animals. Wouldn't that be good if it told you on the first day or on the second day? There is another aspect that you could read about. It is called plant phenotyping. This is where you get your computer vision model to know the characteristics of a given plant. Let's say its leaf size and the area and how it looks. Exactly, you would know that a maize leaf is different from a bean leaf. And now if your computer model is able to tell from seeing the kind of venation and the length of the leaf to know that maybe this is a maize leaf and this is a bean leaf, that would be good. Phenotype describes the relationship between the plant's genotype and then its environment. Now, always you would want to know things like color of the leaf, then its size, its venation, and if all that can be done using a machine, using a computer vision model, it would be good. We talked about various items that included autonomous harvesting robots, plant phenotyping, yield estimation, plant pest and disease detection, then animal welfare assessment. Once again, computer vision is a field of computer science that enables computers perceive their environment as the way humans do. In our next episode, don't get away, we will talk about computer vision and how it is being used in the health sector. For anything else, or if you want us to talk about any sector, please don't forget to put it in the comment section. And if you have not subscribed yet, please subscribe and hit the bell icon to always get notification for new content. Thank you. We will meet once again in part 3, which will be about the health sector. Thank you.